Hello, my name is Mr. Hill, and this is our first attempt at creating a flipped classroom. With our flipped classroom philosophy, you'll watch these videos and take the best notes you can on your own at home. And then when you come to class tomorrow, bring these notes, and we're going to do what you would typically do for homework in class, usually in a small group environment. You'll have greater freedom to interact with your classmates and your teacher and to ask specific questions that are keeping you from mastering the particular topic. As we go through here, perhaps the greatest advantage to you is the fact that you can hit the pause button, rewind, and replay the lesson as many times as you need to, whether it be the entire lesson or just little bits and pieces of the lesson. Also, these videos will be available to you throughout the entire year. So as we get closer and closer to June and we start to review more for the final exam, you can come back to this particular lesson if this is a topic that's giving you trouble later on. Let's go ahead and jump into our first example. Our first quadratic inequality is x squared plus x minus 2 is greater than 0. In my first question, is x equals 10 a solution for this quadratic inequality? All we're going to do to test this is to substitute a 10 into each of the x values in the original quadratic inequality. Now, as we get ready to evaluate this, feel free to use some mental math or to throw the whole thing in your calculator to help you do the number crunching. But I've got 100 plus 10 minus 2 for a grand total of 108. And we're simply going to ask ourselves, is 108 really greater than 0? And I would say true. And what that indicates is that yes, x equals 10 is indeed a solution. My second question, if we stick with the same quadratic inequality, x squared plus x minus 2 is greater than 0, I now want to ask you, is x equals negative 1 a solution or not? If we go ahead and we substitute the negative 1 in for x, I've got negative 2 greater than 0. And is negative 2 truly greater than 0? I would say certainly not. Certainly that is a false statement. Therefore, x equals negative 1 is not a solution to this quadratic inequality. What we're going to find out if we continue to play along with this procedure is that there are many, many solutions to this particular quadratic inequality. The trick is, how do we find all of them? Hopefully, the following steps that we go through will help you find all of the solutions to this quadratic inequality. In fact, I'm going to make a statement that may leave you scratching your head now, but will hopefully make more sense after we do a couple of examples. I'm going to make the claim that there are an infinite number of solutions to this quadratic inequality. However, not all values of x not all numbers are solutions. Our first step is going to be to rewrite the inequality as an equation and then to find the roots the way we have been doing the past 2 weeks in class. So the first thing we'll say, now it equals 0. Certainly we got a very friendly one to start with, as you'll notice that it factors quite nicely. X plus 2 times the quantity x minus 1. And as we tee that up, we'll notice that the roots are x equals negative 2 and x equals positive 1. And just a quick review, all those roots are, is that indicates where this parabola crosses the x-axis if we were to graph it. Our second step is the most intensive step of our entire process. Step 2 is to construct a sign chart. So I'm going to draw a really nice long sign chart that extends all the way from negative infinity to positive infinity. And I'm going to recognize where our roots fall on this number line. So our first interval starts with negative infinity and ends with negative 2. I'm going to pick what I consider to be the friendliest number within that interval. Just so happens that I think that negative 10 is a very friendly number, and that's considered my test value or my test point. What I'm now going to do is I'm going to substitute the negative 10 back into the original quadratic that we had at the beginning. Negative 10 squared plus a negative 10 minus 2. By the time we work that all the way out, I ended up with 88. Now, I'm not so worried about the fact that it's an 88. What I'm mostly focusing on is that I got a positive answer. So what we're trying to say is that any number that falls between negative infinity and negative 2 produces a positive number when plugged into our original quadratic. The second interval starts with negative 2 and ends with positive 1. The friendliest number within that interval is certainly a 0. Substituting a 0 into the original, 0 squared plus 0 minus 2 gives me a negative 2. Again, the fact that it's 2 doesn't concern me as much as the fact that it's negative. Every x value between negative 2 and positive 1, when substituted into the original quadratic, produces a negative answer. Last but not least, our third interval starts with 1 and ends with positive infinity. I think the nicest number in that interval might be a 2. You could certainly pick a 3 or a 4 or a 10. Any number that falls between 1 and infinity would work nicely. Substituting the 2 back into the original, we end up with a final answer of 4. And that's certainly a positive number. At this point, you've finished constructing your first sign chart. Our third and final step is to now identify your answer. We're going to do this in two ways. First of all, we're going to identify our answer graphically, and then we're going to identify our answer using what we call interval notation. And just so you don't have to scroll back up, I've rewritten the original quadratic inequality, x squared plus x minus 2 is greater than 0. Now, when we say greater than 0, mathematically that's referring to positive numbers. So if you refer back to the sign chart you just made, when did we get positive answers? Well, every value of x that was less than negative 2 produced a positive answer, so we'll shade in that interval. And also, every value of x that was greater than 1 produced a positive answer, aka greater than 0. So, representing our answer graphically is simply a matter of shading in the appropriate intervals on our number line. Now, part B, in order to identify our answer using interval notation, we're simply going to use some notation that we used it in the second week of school, where we said all values of x such that x is either less than negative 2 or x is greater than 1. Any x value that falls within those two intervals is a member of our solution set. You've now finished your first quadratic inequality. Let's try a second one. The second quadratic inequality we want to attempt to solve asks us to solve x squared minus 4x minus 12 is less than or equal to 0. Now you'll notice we didn't just say less than 0, we said less than or equal to 0, which in the back of my mind I'm going to make a mental note that I'm going to use closed circles on my number line later on in the problem. That's just one little tip that we often forget when we get to the end of the problem. If you recall from our last example, step 1 said we want to rewrite the equation, rewrite the quadratic in terms of an equation, and then try to find the roots. Again, all of our examples today will be very friendly quadratics that factor quite nicely. And as we tee this up, we could say that our roots are x equals positive 6 and x equals negative 2. Step number 2 is to construct a nice sign chart that extends from negative infinity to positive infinity. We'll recognize our two roots as negative 2 and positive 6. And now we're going to try to pick some friendly numbers that fall within those intervals. Last time I used negative 10 for the first interval. This time, just to prove to you that it doesn't always have to be negative 10, I'm going to choose negative 4. And as I plug that into the original, I'm going to say negative 4 squared minus 4 times negative 4, minus 12. And as I work that out, I ended up getting a positive 20. Be very careful when typing that into your calculator. Make sure you use the appropriate parentheses just as we've used here as we've written it out. The bottom line is that we got a positive answer. That's what we're really focused on. My second interval starts with -2 and ends with +6. The friendliest number with the net interval is 0. Certainly you could have chosen a +1 or a +2 or any number that falls between -2 and 6. As we plug that into the original, we have 0 squared minus 4 times 0 minus 12. As we work that out, we get -12, our focus being on the fact that we got a negative answer. Last but not least, our third interval starts with 6 and ends with positive infinity. I'm going to pick a 10. 10 is always a nice number to work with. 10 squared minus 4 times 10 minus 12 gives me 48. Focus being on the fact that we got a positive answer. At this point, we've finished our sign chart, and we're going to move on to our third and final step. Our third step says we need to identify our answer in two ways. First of all, graphically. We're just going to reconstruct a number line, roots being at -2 and +6. And you'll recall that our original quadratic inequality said less than or equal to 0. So that means mathematically we're looking for negative numbers. The only interval that was negative was the one in the middle here. So I'm going to put a closed circle on -2, a closed circle on +6, and we're going to shade in between those two closed dots. Any number in between -2 and +6 produced a negative value. The second way we're going to identify our answer is using interval notation, and we're going to say all values of x such that -2 is less than or equal to x, which is less than or equal to 6. And that's just our way of saying that any number that falls between -2 and +6 is a member of our solution set. Well, ladies and gentlemen, we finished two examples. Let's try one more just to be safe. Our third and final example looks like this. And you'll notice we did try to sneak in a mini bear trap here. Whoops, time out. I already goofed this one up. I want to try to put an X on this side. So did you recognize our bear trap? This quadratic's not in standard form yet. We always want to make sure that there's a 0 over here on this one side. So simply, all we're going to do is subtract that X over, and we're going to put it right in the middle. That's our B term. Once we subtract that X over and get it so there's a 0 on the right side, now it's in what we call standard form, and we're ready to go ahead. I'd encourage you to try to hit the pause button here and to try to solve this one on your own, and then go back, hit play, and see if you got the same solutions that I did. Step 1 says I'm going to rewrite the quadratic as an equation and go ahead and find the roots as we normally would. Again, it factored very nicely. X minus 4 times the quantity x plus 3. Why did we get -4 and 3? Well, certainly, if you add these two numbers together, you'll get a coefficient of -1, and if we multiply them together, we'll get a coefficient of -12 for the C term. As we tee it up, we have roots of +4 and -3. Step number 2 wants us to construct a sign chart that extends from -infinity on the left side all the way to positive infinity on the right side. We'll identify our roots as being -3 and +4, and we're going to pick some nice test points that fall within these intervals. I'm going to choose -4 as a test point. And as I plug that into the original quadratic, I ended up getting a +8, which is certainly a positive number. In our second interval that starts with -3 and ends with 4, my favorite number of all time, 0. We plug that into the original quadratic, and I got -12. Certainly a negative number. Last but not least, our third interval starts with 4 and ends with positive infinity. I'm going to pick a 5. And as I plug that into the original quadratic, I ended up with an answer of 8, which is positive. We've now finished our sign chart. Our third and final step is to identify our solutions. Now, just to refresh your memory, our original problem said x squared minus x minus 12 wanted to be greater than 0. Greater than 0 implies that we're looking for positive numbers, aka the plus signs that we used up here. On our number line, once we identify our roots, I'm going to use open circles because our inequality was greater than. It did not say greater than or equal to. And then I'm going to shade to the left of negative 3 and also to the right of positive 4. If we want to represent our answer using interval notation, we could say all values of x such that x is less than negative 3 or x is greater than positive 4. Well, there we go. We've just finished our first flipped lesson. Hopefully we took some good notes, and when we see you in class tomorrow, we'll be ready to try some more examples together. Good luck.